Hello, in this video I will review the answers to Quiz 5 review. So the first problem states the following. The average amount spent at Vroman's bookstore for a regular customer is $24.50. The standard deviation is $3.45. If the distribution of the dollar amount spent at the store is a normal distribution, compute the chance that a customer will spend more than $29. Step 1, we draw the normal distribution because it's telling us that the sales follow a normal distribution. The average, 24.50, goes in the center. Standard deviation, we note it down. And we're looking for the chance that the customer will spend more than $29. So we have to find this area. This area represents the desired probability. Now the next step is we convert this to a z-value. So z is your data value minus the mean divided by the standard deviation. The data value is 29 minus the mean is 24.50 divided by the standard deviation. Subtract, divide, round to two place values. Next, we calculate the area. So we look up our z-value. I like to always draw a z-axis below the original values. 29 converts to 1.3, 24.50 converts to 0. We look up 1.30 in the table, 1.30.9032. Remember, that's the area to the left. We desire the area to the right, so we take 1 minus 0.9032, which is 0.068. To compute the answer on the calculator, we type second bars, select normal CDF. We're going from left to right, so our lower value would be 1.3. The upper value has to be the highest value that the calculator can handle. That's 10 to the 99 power. Leave the mean at 0, standard deviation at 1. Press enter and press enter one more time. Round the answer to 4 places. We get 0.0968. That is the probability. Problem 2. The average score on the GMAT exam is 580 points with a standard deviation of 96 points. If a person is guaranteed admission to an elite private MBA college, if that person scores in the top 8%, find the cutoff score. So once again, we're using the normal distribution because it says here, assume the distribution is normal. The mean is 580, standard deviation 96. We're given an area of the top 8%, which converts to 0.08. So this area is 0.08. We have to find the cutoff score, which is X. So our next step is we find the missing z-value. Now, if we use the table, we need to find this left area. To do that, we take 1 minus 0.08.92. Now, we could then use our table to look for the area closest to 0.92. So if we look in our area, we have to look in the middle of the table for the area that's closest to 0.92. That would be this area here, 0.9207. And that's going to give us a z-value of 1.41. So another way to do this is to use the graphing calculator. We type second distribution. We go to inverse norm. Hit enter. We type in the area. In this case, we would type in the 0.92. Leave the mean 0, sigma 1. Press paste. Select enter again. If we round, it'll round to 1.41. The final step, we plug it into the cutoff score. X is mu, which is 580, plus the z-value 1.41 times standard deviation 96. We calculate this. We end up with 715.36, and then we could round to a whole number as it, because typically the GMAT scores are whole numbers. So the answer is 715. Let's look at number 3. It says the average number of cat videos watched on YouTube per day is 12,000, with a standard deviation of 15,000 views per day. Find the cutoff score for the middle 48% of cat videos watched. Assume the distribution is normal. So we have a normal distribution. 12,000 is the average. 1,500 is a standard deviation. Now, when it's a middle 48%, we divide that by 2 to get 24%. So we put 0.24 on the left side of the mean and another 0.24 on the right side of the mean. This represents the middle 48% of the area. So we want to find our two corresponding z-values. I like to focus on the left side. So we need to get this left tail area. Remember, this whole left side is equal to 0.5. So we take 0.5 minus 0.24 to get 0.26. We can then look up 0.26 in the table. So we're looking inside the area section for 0.26. And the area closest to 0.26 is 0.2611, which gives us an area of negative 0.64. So negative 0.64. So another way to do this is we can use the calculator. We type second distribution, inverse norm. We type this left area of 0.26. Leave everything else, leave the mean as 0. Standard deviation is 1. Highlight paste, hit enter. Enter one more time to get negative 0.64. Yes, so this z-value has to be negative because it's to the left of 0. And then by symmetry, since these two areas are the same, the z-value on the right side is positive 0.64. We then plug these values into our cutoff score. So we have 12,000 as the mean minus the z-value 0.64 times the standard deviation. That's going to give us 11,040. The second cutoff score is 12,000 plus 0.64 times 1,500, 12,960. Thus, the middle 48% is between 11,040 to 12,960 videos. Okay, problem 4 says the following. A researcher determines that the average time people spend shopping for Christmas presents is 20 hours. For a sample of 50 shoppers collected, compute the probability that the mean time spent shopping for Christmas presents for the sample is greater than 23 hours. Population standard deviation is 4.3 hours. Here we're using the central limit theorem because we're given a sample of 50 shoppers and we're looking to find the area of a mean. So this is the normal distribution. It has a normal shape, but it's really a distribution of sample means. So the mean is 20. We're given n is 50, standard deviation 4.3, and we're looking for the area that's greater than 23. So we want this right tail area. Now to calculate the z-score, we have to use the z-value for the central limit theorem. So it's the sample mean, which is 23, minus the population mean, 20, divided by the standard deviation 4.3 over the square root of 50. So I'm going to key that into the calculator. I like to use parentheses. So we have 23 minus 20, close the parentheses, divided by, once again, use parentheses for the denominator, 4.3, divided by the square root of 50. Close the parentheses. Hit enter. The z-value is 4.93. So we draw the z-axis. We have 4.93. We can look this up in the table. Remember, when the z-value is above 3.49, the area to the left is 0.9999. 1 minus that gives us an area of 0.0001. That's the answer. We have another question involving the central limit theorem. It says a gym manager determines that the average time spent by members at the gym per week is 10 hours. She collects a sample of 40 random gym members and desires to compute the chance that the mean time spent by the members is between 9.8 and 12.3 hours per week. Population standard deviation is 2.9. Compute the following area. So once again, it's a central limit theorem. Sample size is 40. Standard deviation is 2.9. The average is 10, so that goes in the middle. And we're looking for the area between 9.8 and 12.3. So this is the area we're searching for. That represents the probability. So we have to use the z-values for the central limit theorem because we're given a sample size here. We calculate the first z-score, negative 0.44. Calculate the second z-score, 5.01. So we're trying to find the area between negative 0.44 and 5.01. We look up both areas in our table. So if we look up 5.01, remember when the z-value is greater than 3.49, it's 0.9999. That's the first area, 0.9999. Whenever we're trying to find the areas between two z-values, we always subtract the two areas. So now we look up negative 0.44. So negative 0.44, 0.3300, and that's going to give us an area of 0.6699. Problem 6 is just having us look up areas for the given expression, and this is under the standard normal distribution. Here we want the area to the right of 2.35. So we can use the table. We just look up 2.35. So here's 2.3, and then 5 is 0.9906. Whenever we look up the area, it's always to the left. We want the area to the right, so it's 1 minus 0.9906, 0.0094. We could also calculate this with the graphing calculator. We press second distribution or bars, and we go to normal CDF. The lower value is 2.35. The upper value would have to be the highest value the calculator can handle, 10 to the 99. Leave the mean at 0, standard deviation at 1. Select paste. Enter one more time. And we could round the answer to 0.0094. Now for part B, we want the area to the left of 1.26. In the table, we just look up 1.26. So 1.26 is 0.8962. That's the answer. Now, if we want to use the calculator, we type second bars, normal CDF. Remember, we want the lowest value the calculator can handle. That's negative 10 to the 99. That's your lower limit. The upper limit's 1.26. And then leave 0, 1, and select paste. Hit enter. Enter one more time. This rounds to 89.8962. And for part C, we want the area between negative 0.899 and 0.24. So whenever we want the area between two z-values, we look up both z-values and subtract the areas. So for 0.24, we have 0.24, the area is 0.948. And then for the other value, any value below negative 3.49 is 0.0001. So we're going to subtract those two areas to get the answer, 0.5947. Our next problem, they give us an area. We have to find the unknown z-value. So we'll work it out with the table and the calculator. So to find the area, we need this other area. So that's 1 minus 0.0401, 0.9599. We then look that area up in our table. So we have to look for 0.9599. That's going to give us 1.75. So 1.75. Now, if we use the calculator, we do the following. It's second distribution. We go to inverse norm. The area to the left is 0.9599. Leave the mean 0, standard deviation 1, select paste, hit enter one more time, and that rounds to 1.75. Okay, thank you for watching this video.